What are two-port networks? Often, one engineer doesn't make all the system, or maybe different companies make assembled single system because different inputs and output characteristics of different components. You have to specify what are the input and output characteristics of such systems. Mostly in electronics and electrical engineering, the input is in the form of voltage and current. Also, the output is, of course, is obtained in voltage and current form. The system developers will not expose or will not tell anybody that what is exactly in their black box. That's what we call a black box. The component design that we don't know. We just know what input in the form of current that is happening and what is the input voltage that we are giving, what voltage that we are going to obtain, and what current that we are going to obtain. So there are these four mostly commonly used variables, which are V1, I1, V2, and I2. Now, with the combination of these four variables, we can form different equations by assuming two of them to be dependent and two of them to be independent. Now, for an instance, in this particular presentation, we are going to see what are impedance parameters. So we will see what exactly is the choice of dependent and independent variables. So let us quickly scan through what two-port networks are actually about. So the two-port networks refer to the input and output arrangement of leads of a black box. These are four main variables in two-port networks: input voltage and current, input and output voltage and current. So these are the four main variables. Two of these unknowns will be considered to be known and two will be considered unknowns. So basically, out of these four, we can assume any two to be known and any two to be unknown, and we can form equations which are two equations and two unknowns. Different kind of two ports are formed by different choices of the known and unknowns. Alright. So whenever we choose V1 and I1 as knowns and V2 and I2 as unknowns, we will get different parameters than when we choose I1 and I2 known and V1 and V2 to be unknown. So there are different permutations and we get different kind of parameters. So two-port networks, we have the I1 and V1 as input voltage and current, I2 and V2 as input output current and voltage. As you can see, the currents are going into the network. So these are the conventional directions of currents. Alright, and this is positive, negative. This is positive, negative. As I told you, we are going to see impedance or Z parameters and what are they all about. So for Z parameters, as you can see, Z is nothing but impedance. Alright, so we are going to see how impedance parameters work and formed. So dependent variables are taken as V1 and V2. Dependent means these will be dependent upon some other known values. So V1 and V2 are unknowns or dependent. Alright. Independent variables will be I1 and I2, whose values will be known or given to us. Known values. Now to form equations, we can easily see V1, we can form an equation as V1 is equal to I1 into Z11 plus I2 into Z12. V2 is equal to I1 into Z21 plus I2 into Z22. As you can see, value of Z11 is equal to V1 upon I1 when I2 is equal to 0. That means when we have this as an open circuit, there will not be any current flowing through the second port, and then the V1 upon I1 will give us Z11. This is known as input resistance. Alright, this is known as input resistance. Similarly, for Z22, when I1 is equal to 0 or first port is open circuit, V2 upon I2 gives us Z22. Z12 and Z21 are transfer resistances which have the dimension of resistance itself, voltage upon current. So every parameter is of dimension of impedance, and hence these are called as impedance parameter. Alright. So you can find out Z12 as V1 upon I2 and I1 is equal to 0 at that time, and for Z21 you have V2 upon I1, which gives at I2 is equal to 0. Let us see a live example for this. So this is how you can represent a two-port network impedance parameter, wherein Z11 is nothing but having an impedance value. Then you have Z12 into I2 giving the dimension of voltage source which is dependent upon the current I2. That is why we have a diamond here. This is the dependent voltage source. Similarly for Z21 into I1 we have a dependent voltage source. V1 is made up of I1 into Z11 into plus Z12 into I2. Similarly this one. Now we have example 6.1 wherein we need to find out the values of Z parameters. That means we need to find out what are Z11, Z12, Z21 and Z2. Now there is a way to find this out. We need to apply KVL or KCL and to develop equations in V1 and I1. Another method is, as we saw in the previous slide, the Z11 is nothing but V1 upon I1 when this particular terminal is open circuited. We can use this process also. While finding out Z12 and Z21, alright, we can put a voltage source of 1 volt and solve for the circuit, and we can find out the value of Z12. Z12 is nothing but V1 upon I2 when V2 is 0. So in this circuit, we need to find out all these values. I am interested in developing some equations applying KVL in each loop so that I get different equations in the form of V1, I1, V2 and I2. I am going to assume current I3 flowing through this loop, which I am going to eliminate. Now assume this is current I1 flowing through this particular branch and this is I2 flowing in this particular loop. Applying KVL in this particular branch gives me I3 into I1 plus 3V1 plus I3 plus I2. I3 and I2 are both going in this direction. So 1 into I3 plus I2 plus I3 minus I1 is equal to 0. So this is KVL. This is the equation. If I solve this equation, I get this I3 and this I3, 3I3 and all the other things taken on the right hand side, which gives I1 minus I2 minus 3V1. Also, I am going to apply KVL in this loop and also in this loop. Applying KVL in this loop gives me V1 is equal to 2 ohms into I1 minus I3. So this is the equation while I apply KVL in this loop. If I solve this, V1 is equal to 2I1 minus 2 into I3 and putting the value of I3 minus 2 upon I1 by 3. So 3I3 is this. So I3 will be this divided by 3. So minus 2 by 3 I1 plus 2 by 3 I2 plus 2 V1. Alright. Solving this further, I get V1 is equal to minus 4 by 3 I1 minus 2 by 3 I2. Similarly, applying KVL in this particular loop, I get I3, I2 plus I3. I2 plus I3 is equal to V2. And after putting the value of I3, I get such an equation. Solving this makes me find V2 as 5I1 upon 3 plus 4I2 upon 3. Now you have the equations like this. We have already seen in case of impedance parameters, we have V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. So according to the comparison, we have I1 is equal to Z11 is equal to minus 4 by 3, Z12 is equal to minus 2 by 3, Z21 will be is equal to 5 by 3 and Z22 or Z22 is equal to 4 by 3. So this is how you can find out the values of Z parameters or impedance parameters. You can apply KVL or KCL or use any method to find out Z1, Z21 or Z12 and Z22. applying different voltage sources, shorting and opening the terminals, all the all the procedures will fetch you correct values of Z11, Z12, Z21 and Z22. I hope you have understood the Z parameters and introduction to two-port network. I'm looking forward to help you again when you call me back. Thank you so much.